let's explore one more category of models, open source models. We're currently on the second of 3 steps, where we're evaluating models to determine which one to use. Luckily, there's a standardized hub for all open source models at huggingface.co. Visit this URL, and you'll see a ton of options. It's overwhelming. Here are a few heuristics, though, to navigate this large repository of models. Rule number 1, use instruction-tuned models. Usually, instruction-tuned models have instruct in the name somewhere. The reason for this rule is that LLMs are trained in 3 stages. In the first stage, called pre-training, LLMs simply predict the next word. In the second stage, called SFT, or supervised fine-tuning, models learn to answer questions. In the last stage, called reinforcement learning with human feedback, or RLHF, models learn to align answers with human preferences, being helpful, honest, and harmless. Technically speaking, only the second step is called instruction tuning, but practically speaking, instruction-tuned open source models have gone through both SFT and RLHF. In any case, you don't want a model that's only gone through pre-training, because those models auto-complete questions, not answer questions. So in summary, rule number 1, use instruction-tuned models. For rule number 2, use small models. This is obviously not a hard and fast rule, but I strongly recommend it. Now let's say you ignore me. What if you want to use massive open source models, the biggest and the best? Well, let's see which open source model is the best. Here's the chatbot arena. Gemini, OpenAI models, and Grok 4 are all proprietary, so the highest ranking open source model is Kimi K2. Let's go to Kimi K2's website. According to this webpage, Kimi K2 is 1 trillion parameters, so realistically, we would need 16 H100 GPUs to run this model. First, that's expensive. 16 H100 GPUs cost $64 for just 1 hour of usage. Second, it's complicated to run inference for a model this big. All this to say, if you want to use state-of-the-art open source models, you should use APIs serving open source models, because their prices benefit from economies of scale. It's cheaper for you to call an API than for you to run these massive models yourself. For details, you can see this blog post, which I'll link on our course website. To use state-of-the-art open source models, let's follow the same 3 sub-steps: test via chatbot, test via API, and optimize cost. Starting from the first sub-step, let's test via chatbot. Go to gpt-oss.com. Remember, this was our prompt from before. We expect AI to return true, false, false. First, go to this URL and copy the prompt. Then, you'll see a web page like this. I chose to continue with visible reasoning, but you can pick either option. Neither option changes the quality of the AI's responses. Paste in your prompt and hit run. Then you'll see true, false, false, the correct answer. On the left-hand sidebar, now click GPT-OSS 20 billion, the smaller of the 2 open source models from OpenAI. Then, in the top right, click on New Chat. Your screen will then look like this. Paste in the prompt once more and hit run. Then once again, you'll see true, false, false, the correct answer. We've seen that the best of open source AI can complete our task. Now, let's retest via API. On huggingface.co, many open source models have a section in the bottom right where you can send one-off messages to the LLM to test it. This is also not free technically, but you can send requests without adding billing information. Paste in your prompt, and DeepSeek R1 passes. It outputs true, false, false. That means open source AI, like DeepSeek, can also solve our task. DeepSeek R1 would have costed 1/3 of a cent to run this example. Like before, let's now find the cheapest model that can complete our task. Let's try the next cheapest model, DeepSeek R1 Llama 7 billion. This model also gets the answer correct, true, false, false. DeepSeek Llama costed us 1/6 of a cent, so we've now lowered our cost by half. Now let's try the next cheapest, DeepSeek V3. Technically, DeepSeek V3 answered true, false, false correctly. It just did so with a lot of extra text. Unfortunately, if DeepSeek outputs different formats each time, our project code would not be able to parse LLM output reliably. Luckily, we have a way to fix this, which I will show you later. But for now, DeepSeek V3 doesn't pass. It has the intelligence, but not the formatting. Let's try the next cheapest on our list, Llama 3 70 billion. Hugging Face unfortunately keeps giving me errors, so I found a random other website. I don't necessarily endorse, but any website will do. And it looks like Llama 3 70 billion answers correctly with true, false, false. So Llama 3 70 billion passes. Let's try the next cheapest model on our list, DeepSeek's Qwen. DeepSeek R1's tiniest distilled model just spits out an infinitely long string of tags, so this is a hard failure. Qwen failed catastrophically, as we saw. And with that said, we've now completed our table of results. We can relist all prices in cents, then compare OpenAI pricing with open source pricing to compare intelligence per dollar. Here are the winners of each category. Notice the difference in cost. Granted, I could have tested smaller open source models that are cheaper than 70 billion, but more capable than Qwen. But any smaller, and they can be run on your own machine for free, so there's no point in testing their APIs. The OpenAI API is 15 times cheaper for this specific task, for detecting non-food critiques correctly, based on our previous results. Generally, for the cutting edge class of models, proprietary models outperform open source models on intelligence per dollar. So if we're considering open source, let's step away from cutting edge and stick to small open source models. These models can actually be really economical to run on your own. So in summary, I recommend using small open source models. At least for now, for the large state-of-the-art open source models, we've completed our 3 sub-steps. This completes evaluation for large open source models. In the next lesson, we'll look at small open source models, small enough to run for free. As usual, you can find all links, notebooks, and other resources on the course website.